this video, we're going to find the determinant of a 3 by 3 matrix using minors and cofactors. Suppose we have the 3 by 3 matrix A equals 0, 2, 1, 3, -1, 2, and 4, 0, 1. You can find the determinant of this matrix by expanding your cofactors in any row or column. Generally, it's easiest to do this with a row or column that contains 0, since it reduces the amount of calculations. Let's find our determinant by performing an expansion by the cofactors of row 1. Let's start by finding our minors and cofactors for row 1. I'll begin by finding the minor and cofactor for row 1, column 1. You'll see later in the problem that it wasn't necessary for us to perform this part of the calculation since the entry is 0, but I'm going to calculate them anyway so that you can see why. So, the minor for row 1, column 1 is equal to the determinant of -1, 2, 0, 1, which gives us -1 minus 0, or -1. The cofactor for row 1, column 1 is -1 to the power of 1 plus 1 times the minor for row 1, column 1. So it's -1 to the power of 2 times -1. That gives us -1. Next, let's look at the minor for row 1, column 2. That is the determinant for 3, 2, 4, 1, where we multiply 3 times 1 and subtract 4 times 2 from it to give us -5. And our cofactor for row 1, column 2 is equal to -1 to the 1 plus 2 times -5. So that gives us -1 times -5, which equals 5. Next, we want the minor for row 1, column 3. So we obtain that by taking the determinant for the 2 by 2 matrix, 3, -1, 4, 0. And that equals 4. Our cofactor for row 1, column 3 is equal to -1 to the power of 1 plus 3 times 4, so the cofactor is 4. Now, we can obtain our value of the determinant by multiplying the value of our cofactors with the entries along row 1. Our first entry is 0 times our first cofactor, -1, plus 5. Actually, let's take that out, put our entry first. So we have 2 times 5 plus 1 times 4. So you'll notice right here that because the entry in row 1 is 0, it was not necessary to calculate the minor and cofactor. That's why we like to do our expansion using any row or column we can that contains a 0, because then it greatly minimizes our workload. So we really only had to calculate minors and cofactors for these two entries and take their sum. 2 times 5 is 10, plus 1 times 4, which is 4. So it turns out that the determinant for our 3 by 3 matrix is equal to 14. This concludes our example. I hope you found it helpful, and we'll see you next time.